Hello everyone, this is our session 6 on matrices. We were on the miscellaneous exercise 2A, question number 7. Okay, so we had finished the third question of question 7. You have to find the inverse if the inverse exists for the matrices given. So first of all, we'll check whether it is the matrice is invertible by finding the determinant value. If it's non-singular, then yes, the A inverse exists. Okay. Then the next thing is you can use two methods, either your elementary row and column transformations or the adjoint method. So I would suggest for the 2 by 2 matrix, you can go for the elementary transformations. And for the 3 by 3 matrices, you can go for adjoint method, whichever you find easier. Also, I have done the third question of question 7. Now I'm doing the ninth one. If you have any doubts in the others, you can write to me so that I'll solve the sum and give it to you. Because we cannot do all the sums, they're quite simple. You can do them on your own as well. So let us begin with question 7, the ninth one. I'm using elementary row and column transformations. Adjoint method is comparatively simpler, so that you can try it through that method as well. Question 7, we're doing the ninth one. Okay, so the ninth one is, let us call the matrice as A. A is equal to 2, 0, minus 1, 5, 1, 0, and 0, 1, 3. So our first step is to check whether the inverse exists, right? So how do we do that? We find the determinant value, right? Determinant value, how will we find? So determinant of A is equal to 2 multiplied by 3 minus 0 multiplied by 15 minus 0 minus 1 multiplied by 5 minus 0. Okay, so we have 6. The middle term is 0 minus 5, that is 1. So yes, A inverse exists. Okay, you have to write this and then we can go for the method. So I'm going for elementary row transformations. A inverse is equal to I. Let us write a matrix A, 2, 0, minus 1, 5, 1, 0, and 0, 1, 3. Okay, A inverse is equal to 1, 0, 0, 0, 1, 0, 0, 0, and 1. Okay, so row transformations, what is the first step? That the corner element A11 has to be made 1. So how do we do that? R1 we'll divide by 2. Okay, so row 1 changes to row 1 divided by 2. So we have 2 divided by 2, 1, 0 divided by 2, 0, and minus 1 divided by 2 is minus half. Okay, then we have 5, 1, 0, 0, 1, and 3. Okay, and your A inverse as it is. Here we'll have 1 by 2, 0, and 0. R1 is changing, right? So we'll have 1 by 2 over there. Okay, right? What should be the next step? When we do use row transformations, you go on reducing the column elements. That means I first make the A11 as 1, then the elements below it, I make them 0. So one of them is already 0. We'll make A21 as 0. That is 5 is to be made 0. So how will we do that? The transformation will be R2 changes to R2 minus 5R1. Okay, so let us do this. Second row is changing, so first row remains as it is, 1, 0, and minus half. Okay, second row changes, 5 minus 5, 0. Five minus 5, 0. Okay, 1 minus 0 is 1. Okay, and the last one, 0 minus 5 into R1. So 0 minus of minus, that is plus 5 by 2. Okay, minus of minus, so plus 5 by 2. Okay, and here we will have the elements as it is 0, 1 and 3. 0, 1 and 3. Okay, A inverse as it is equal to, and your the matrice on the right side also changes. So we will have half as it is 0, 0. Then 0 minus, what do we have? 0 minus 5 by 2. So minus 5 by 2. Okay, this will remain as it is. Okay, yes. So the next transformation is to make A22 as 1. Now A22 is already 1, second row, second column. So what do? The elements above and below it have to be made 0. Above is already 0. The one below it has to be made 0. So how will we do that? R3 is equal to, or R3 changes to R3 minus R2. Okay, so we have 1, 0 minus half, 0, 1, 5 upon 2, and R3 is changing. So 0 minus 0 is 0, 1 minus 1 is 0, and 3 minus 5 by 2. That is 6 minus 5 by 2, 1 by 2. Okay. Yeah. And A inverse as it is equal to, okay, what will, only row 3 is changing, so we'll just copy the other two rows, minus 5 by 2 over here, 1 and 0, and 0 minus R2. So 0 minus of minus will be plus 5 by 2 will be 5 by 2 here. Okay. Then 1 minus 1 will be, one second, one element we've written wrong over here. It should be 0, 0, 1. Yeah. Yeah. Yes, it should have been 0, 0, 1. Okay, 0 minus 1 is minus 1, 1 minus 0 is 1. Okay, this is done. Now see, so when we make a small mistake, from there on all your mistakes begin. Okay, so remember to copy the elements correctly. Okay, now what do we have to do? We have to make the A33 element, the diagonal element, as 1. So how will we do it? We can say that R3 is multiplied by 2. If I do that, that is R3 changes to 2R3. Then I'll have 2 multiplied by half, that is 1. So let us write this one. R3 changes to 2R3. So we will have 1, 0, and minus half, 0, 1, and 5 by 2. Okay, and then 0, 0, and 1. In the third row, only there is one element, that is half, and that we have to change to 2R3. So 2 into half is 2. A inverse as it is. Again, in the right side, the first two rows remain the same, half, 0, 0, minus 5 by 2, 1 and 0. Now the third row is changing. What is the third row have to become? 2 into R3. So 2 into 5 by 2 is 5. Okay. Then 2 into minus 1 is minus 2. Okay. And the last element 1, 2 into 1 is 2. So this becomes 2. Okay. Now the next step, we'll go from here, we'll make these two elements 0. So 5 by 2 has to be made 0. So what can we do to make that as 0? We can say that R2 changes to R2 minus 5 by 2 R3. Now R3 is 1, right? So when you multiply it with anything else, it will take the number itself. So we'll have 1, 0 and minus half, 0, 1. Okay, R2 is changing. So 0 minus 5 by 2 into 0 is 0. 1 minus 0 is 0. And the last element 5 by 2 minus 5 by 2 is 0. And the third row remains as it is. Okay, A inverse is equal to, okay. Now R2 is changing. So first row we'll write as it is. Minus 5 by 2 minus 5 by 2 into R3. So that will become 25 by 2 minus 15. Okay. So what is the calculation over here? I'll just write it down over here. So you have R2 that is minus 5 by 2. Okay. Minus R3 that is 5. So minus 25 by 2. So that is minus 30 upon 2 is minus 15. Okay. It's minus 15. Then the next one is 1 minus 2 into 5 by 2, that is minus of, so 1 minus 5 by 2 into minus 2, right? This becomes plus, and 1 plus 5, that is 6. So this element will become 6. Last one, 0 minus 5 by 2 into 2. So we have 0 minus 5, that is minus 5. Okay, and the last row remains as it is. Okay, now what is remaining? Only this element over here, minus half, has to be made 0. How can we do that? Simple, R1 changes to R1 minus, sorry, R1 plus, because R1 is already minus half, so we write R1 plus R3 upon 2. Okay, so let us do this transformation. So we'll have R1 is changing. Okay, so bracket. Now R1 plus R3 upon 2, 1 plus 0 is 1 and 0 plus 0 is 0. So first two elements are not changing. The next one, minus half plus R3, that is 1 upon 2. So minus half plus half, 0. So the remaining elements remain the same. They do not change. This is A inverse is equal to, okay. Now R1 is changing. So half plus R3 upon 2. Half plus 5 upon 2, that is 6 upon 2, that is 3. So the first element is 3. Then 0 plus minus 2 upon 2. So 0 minus 1, that is minus 1. Then we have 0 plus 2 upon 2, that is 1. So this will be 1. The remaining elements as it is, minus 15, 6 and minus 5. Okay. 5 minus 2 and 2. 5 minus 2 and 2. Okay, so this is your identity matrix. IA inverse is equal to 3 minus 1, 1, minus 15, 6 and minus 5, 5 minus 2 and 2. That means A inverse is this matrix that we have found out, because I into A inverse is A inverse. So 3 minus 15, 5 minus 1, 6 minus 2, 1 minus 5 and 2. Remember, if you don't want to do the elementary transformations, you can also use the adjoint method to find the inverse. Okay, let us go to the next question now. I am not solving any more of question 7, but if you have any doubts in those questions, any sum that you were not able to solve, you can write to me. I'll send you the solution. Okay, question 8. Now question 8 is based on trigonometric ratios. That means inverse of a trigonometric matrice. Okay, so let us begin that. A is equal to, there is a special way in which we do these sums. Cos theta minus sin theta 0, sin theta cos theta 0, and we have 0, 0, and 1. And what we have to do in this question 8 is using row transformations, and that means first time we will use row transformations, and second time they've asked us to use column transformations to find the inverse. Okay, so let us begin first with the row transformation. So for that, let's check the determinant value first. So we have cos theta multiplied by cos theta. Okay, minus of minus becomes plus sin theta. Okay, and we have sin theta over here, and the last term is plus 0. So whatever is in the bracket would be 0. Cos square theta plus sin square theta is 1, and therefore the A inverse exists. Okay, so we now know that the A inverse exists. Now what is the row transformation? How will you do the row transformations for this? So we'll first write it in the form of AA inverse is equal to I. So we will have our A matrix, that is cos theta minus sin theta and 0, sin theta, cos theta, and 0, and 0, 0, and 1. Okay. A inverse is equal to your identity matrix. Yes. Now, we are going to perform row transformations. Normally when we had numbers, we would directly divide by cos theta, or we could say that the first term A11 is to be divided by the number that we have over there. Let's say if we have 2, then we do divide by 2 to get 1. Okay, but here we'll use a different method because we have trigonometric functions. We'll use identities to get 1 over there. So which identity would get you 1? It is cos square theta plus sin square theta, right? So we'll say that R1 changes to cos theta R1, okay, plus sin theta R2. Okay, what are we doing over here? Cos theta R1, so that will be cos square theta plus sin square theta R, and so that is sin theta into sin theta, so sin square theta. That means when I do addition of R1 and R2 by multiplying cos and sin respectively to them, the first term is turning into 1 using the identity. Okay, so let us perform this transformation. So we will get cos square theta plus sin square theta is 1. See, cos theta into R1, so cos square theta plus sin theta into R2, so sin square theta, that is 1. Next one, cos theta into R1, so cos theta into minus sin theta is minus sin cos. I'll write it over here. Okay, so minus sin theta cos theta. So this we are doing A12 minus sin theta cos theta. Okay. Plus sin theta into R2. So plus sin theta cos theta, which will cancel out, right? So the answer here will be 0. Next one, third element is 0 itself. So 0 into R1 is 0 plus 0 into R2 is 0. So we have that element as 0. Okay. The remaining we'll copy as it is, sin cos 0 and 0, 0, 1. Sin theta, cos theta, 0 and 0, 0, 1. Okay, A inverse as it is, and now here. Now, row 1 is changing. So cos theta into R1. So cos theta into 1 is cos theta plus sin theta into 0. So 0. So cos theta into R1 is cos theta. First element here is cos theta. Second one is 0 into cos theta 0 plus 1 into sin theta, that is sin theta. So the second element is sin theta over here. Next one, 0 into R1, cos theta into 0 is 0 plus sin theta into 0 is 0. So this term remains 0, and remaining we copy as it is 0, 1, 0 and 0, 0, 1. Okay. Now the next thing, what do we have to do after we get 1? This term here, we make it 0, right? So this will be R2. R2 changes to R2 minus sine theta R1, right? So sine theta minus sine theta will give me 0, right? So R2 minus sine theta R1. First row as it is. Sine theta minus sine theta, 0. Cos theta minus 0 is cos theta, right? 0 minus 0 is 0. Remaining elements as it is. Okay, A inverse is equal to. Now, first row as it is because first row is not changing. It's the second row that is changing. So second row is R2 minus sine theta R1, 0 minus sine theta cos theta. So I'll write this as minus sine theta cos theta. Okay. Second one is 1 minus sine square theta. What is 1 minus sine square theta? It is cos square theta. So this term is cos square theta. 0 minus 0 is 0 and 0, 0, 1. Okay. Last step, we have to make this term as 1. So what do we do? R2 changes to R2 divided by cos theta. Now when I do this, this left hand side matrix will turn into an identity matrix. What about the right hand side matrix? In R2, when I divide by cos theta, in the first term cos theta cancels, in the second term 1 cos theta cancels. So what will be the answer? So here we will get an identity matrix. Okay, cos theta upon cos theta, so 1. The remaining were already transformed. Okay, here we'll have cos theta, sin theta, and 0. Now row 2 is changing, so minus sin theta cos theta upon cos theta. That cos theta cancels out and we get minus sin theta here. Cos square theta upon cos theta is cos theta alone. 0, 0, 0, and 1. Yeah. So this is what we have got as our A inverse because this is your I. So I A inverse is equal to this matrix here, cos theta, sin theta, and 0, minus sin theta, cos theta, and 0, 0, 0, and 1. So A inverse is this value over here. Now I told you that there is something interesting about trigonometric inverses. What is that? So here we have A as cos theta, sin theta, minus sin theta and 0. Then we have sin theta, cos theta, 0, 0, 0, and 1. Okay, this is A. And your A inverse value is cos theta, sin theta, 0, minus sin theta, cos theta, 0, 0, 0, and 1. Okay, let us observe the two. If you can see, all the elements are same except the sin theta value. That means even sin theta is the same, but the signs are different. That means in A we had minus sin theta over here, and A inverse we are having plus sin theta. Similarly, in A we have plus sin theta in the second row, and in A inverse we are having minus sin theta. If you observe, the remaining elements are the same. Cos theta has remained cos theta. Cos theta in the second row has also remained cos theta, and all the zeros and ones are also the same. That means any trigonometric inverse that you will find out, the answer to it is very simple. You can write it orally as well. This could be an MCQ also as to what is the inverse of a 3 by 3 trigonometric matrix in this format. Okay, so it is very simple. All the elements remain the same, only the value of sign will change. Okay, similar, that is, it will become plus sin theta will become minus, minus sin theta will become plus sin theta. Okay, similar sums can be made from sec and cosec theta, tan theta, and cot theta. Okay, so if you're having those kind of sums also, only this much will change. That is, in tan and cot, tan will change, in sec and cosec, we'll have um, cosec changing. Okay, depends on what is the sum. But if you will observe the inverse and a, then we'll have only sign changes in the answer. So this is the speciality of a trigonometric matrix and its inverse. Okay, let us go to the next question now. Also in the same sum, they have asked you to do column transformations and get the answer. You can try it with column transformation in similar manner. Okay, like we used identity in the first transformation, same way in column also we will use identity and you get the answer matrix. Okay, let's go to the next question now. Question 9. So question 9 is simple that way, but a little bit of calculation is there. We have two matrices A equal to a 2 by 2 matrix 2, 3, 1 and 2, and we have B equal to 1, 0, 3 and 1. Okay, so AB and AB inverse is to be found out. So we have to find AB and then we have to find its inverse. Okay, then they've asked you to verify something. What is that? They said verify AB inverse that you find out is equal to B inverse A inverse. Okay, so basically separate inverses also have to be found out and the combined multiplied inverse also has to be found out. Okay, so we'll first begin with the multiplication and find its inverse. Then we will go to the inverse of the single matrices. Now in here I'm using the adjoint method. It is a little bit faster. Okay, so I'll use the adjoint method to get the inverse. First let's multiply A and B. So A into B is equal to 2, 3, 1, 2 and B is 1, 0, 3 and 1. Okay, let us multiply the two matrices. So the answer matrix will be 2 plus 9 that is 11, 0 plus 3 that is 3, 1 plus 6 that is 7 and 0 plus 2 that is 2. So this is your AB matrix. Now we'll find its inverse. So for finding inverse by adjoint method, what do we do? First we have to find the minus, then they are cofactors, matrix of cofactors and then adjoint. Okay, so let us begin. AB is 11, 3, 7 and 2. So AB is equal to 11, 3, 7 and 2. Okay, yes. To write this page so that the sum is on one page. Okay, now first we'll find the minus. So M11 is 11. Sorry, M11 is 2. You have to hide the row and column of A11. So M11 is 2. M12 is equal to 7. M21 is equal to 3. And M22 is equal to 11. Okay, similarly, we'll find out the cofactors A11, A12, A21 and A22. Okay, so A22. Okay, so what will be the answer? I told you if addition of I and J is even, answer remains the same. So only this will change. Okay, only A12 and A21 will change. Matrix of cofactors will be 2, minus 7, minus 3 and 11. Okay, adjoint of A will be, we'll make the rows as the columns. So 2, minus 7, minus 3 and 11. This is adjoint of A. Okay, now adjoint of AB it should be. So we'll write AB over here. Adjoint of AB is this. So AB inverse, okay, is equal to 1 upon determinant of AB, okay, into adjoint of AB. This is our formula to find the inverse, right? Now, what is determinant of AB? 22 minus 21, that is 1. Okay, so determinant of AB is 1. So 1 upon 1 multiplied by the adjoint. 2 minus 3 minus 7 and 11. Okay, so AB value where we have is, AB inverse, sorry, is 2 minus 3 minus 7 and 11. Okay, this is AB. Now, what do we have to verify? Let's go to the question once. So the question says, verify AB inverse is equal to B inverse into A inverse. So now we have to find the inverse of each of the matrix. So A is equal to 2, 3, 1 and 2. Okay, and B is equal to 1, 0, 3 and 1. What we'll do is, we'll put both the matrix here only on the same page. So we can write B is equal to 1, 0, 3 and 1. Okay, this is A and B. Now how do we find inverse by our joint method? We write the minors and then we write the cofactors. So I'll just quickly write the minors for you. M11 would be 2, M212 is equal to 1, M21 is equal to 3 and M22 is equal to 2, right? A11 is named the same, A12 is equal to minus 1, A21 is equal to minus 3 and A22 is equal to 2. Matrix of cofactors 2 minus 1 minus 3 and 2 and adjoint of A, okay, will be equal to 2 minus 1 minus 3 and 2. Okay, what will be inverse of A? First find the determinant. So let us just write the inverse over here. So A inverse is equal to 1 upon 1 multiplied by your adjoint. What is the adjoint? 2 minus 3 minus 1 and 2. Why have I written 1 upon 1? If you see, the determinant of A is 4 minus 3, that is 1. So this is your A inverse. Now let us find B inverse. So B inverse will be, again, same method, M11 minor of the first element, 1, M12 is equal to 3, M21 is equal to 0 and M22 is equal to 1. Okay, now A11 is equal to 1, A12 change the sign, minus 3, A21 is 0 because no sign change, A22 is equal to 1. Okay, so your matrix of cofactors will be 1, minus 3, 0 and 1. Okay, adjoint of B will be reversing the rows and columns, 1 minus 3, 0 and 1. Okay, and last step is B inverse is equal to 1 upon, what is determinant of B now? 1 minus 0, that is 1. Okay, and 1, 0 minus 3 and 1. So now we have B inverse and A inverse. Let us multiply the two. So B inverse, A inverse multiplied together is equal to, what is B inverse? 1, 0 minus 3 and 1. So 1, 0 minus 3 and 1. What is A inverse? 2 minus 3 minus 1 and 2. 2 minus 3 minus 1 and 2. Let us multiply these. So we'll have the answer as 2 minus 0 is 2. Minus 3 plus 0 is minus 3. Minus 3 into 2 is minus 6. Minus 1 is minus 7. 9 plus 2 is 11. Okay. Now they have asked you to verify. So AB inverse, okay, is equal to, what is AB inverse? Let's write that down here. 2 minus 3 minus 7 and 11. Okay, so 2 minus 3 minus 7 and 11. Is that equal to your B inverse, A inverse separate multiplication? Yes, so we have verified the two. I personally find the adjoint method easier. You can also use row column transformations if you find that simpler. Okay. The next session we will do the remaining sums of the miscellaneous 2A, and hopefully we'll complete it in this week. In the next week we'll start with the second part of matrices. If you have any doubts in these sums that we have solved or any other sums regarding this part of the chapter, do write to me. Thank you very much.